Okay, so today we are getting into chapter 7. So now we're actually getting into solving quadratic equations by graphing. Okay, so let's compare a quadratic function in standard form to quadratic equations. So remember, standard form, we're going to have a x squared plus bx plus c. Okay, the difference between a function and an equation is that a function will equal a variable and an equation is going to equal a number. Okay, so in this case, this shows the relationship between x and y can be seen on a graph. Okay, and that's what we've been doing for the last month or so, right? We've been doing quadratic functions. Okay, for quadratic equations, so note that this is a number, not a variable, right? That's a big one. Okay, it's going to equal a number and not a variable. And in this, when we have quadratic equations, we can solve equations for x and will tell us our intercept / roots.
Wait, you can solve equations for y or for x?
For x. Yeah, so we want to find what...
I just thought that was a y, so I was...
Yeah, this should be an x, sorry.
Oh,
it's a half x. Yeah, so we're going to solve for x, and that will tell us the x-intercepts, okay? X-intercepts, roots, and zeros, those are kind of used interchangeably, okay? They all mean the same thing, okay? So if I'm x-intercepts, roots, or zeros, that is going to be where it crosses the x-axis, right? Or in some cases, we can also have like intersection lines running through. And if this was like y is equal to 5, we could find like an intersection point right here. Questions so far? Okay, good. So, when we are being asked to solve a quadratic equation, you're being asked where ax squared plus bx plus c is equal to 0, okay? This is the same thing as being asked for the roots of an equation, the zeros, or the x-intercepts of an equation. So like, remember when we were in factored form, we were always trying to find what value of x would set the whole like function equal to 0, right? Yeah. Kind of related to that, actually very closely related to that. Okay? Okay. Cool. So, review. So, question for you guys. How many x-intercepts can a quadratic equation have?
2, 1, or 0.
2, 1, or 0. Mm-hmm. You bet. So let's do 0. And then we'll do 1. And we have 2 here. Of course, use 1 forever. And what could I say about my A value in all these cases?
Your A value is positive.
Yeah, for sure. Because they're happy parabolas, right? They're positive A's, good. Okay, so if we can have 0, 1, or 2 roots, or x-intercepts, or zeros, therefore, an equation can have 0/1/2 zeros, 0/1/2 roots, and 0/1/2 solutions, okay? Sometimes there will not be any solutions because our parabola does not cross that x-intercept, right? Okay. So, there are 3 different ways of finding the values of our x-intercepts. So one, you can use our graphing calculator. That's what we're going to be doing today. Later on this week, we're going to get into factoring. Okay, so we're going to do some trinomial factoring, some binomial factoring, difference of squares. Did any of those terms ring a bell for you guys? Yeah? Good. Good. So again, the values of the x-intercepts, so like roots or zeros or x-intercepts. Okay, so if a question asks you guys to find the roots of, or like solve an equation by factoring, you better factor, okay? Don't just graph it and find the x-intercepts, because I won't even give you a part mark for that.
Find it. Again, dude.
Show all your work and do what the question says.
Well, you're gonna be like trying to hit me like Rylan did.
No, he doesn't hate you. Okay, so example 1. So we're going to determine the zeros of the quadratic equation by graphing. So let's go ahead and plot these into our graphing calculators. So get them out, please. Yep, you bet. Yeah. What, you guys just don't bring your calculators? Oh yeah, you brought yours. That's fair. Yeah, and I'm going to do them up here as well. But we don't have Desmos on quizzes and tests, right, Emery?
Totally.
Yeah, I'm gonna have to use that quickly for today.
Okay, so where is it? Here's our function. Negative 4x squared. Where'd it go? There it is. Plus 3x plus 10. Oh, I'm not even typing anything in. Huh. Negative 4x squared plus 3x plus 10. Okay, so here is our parabola, right? Our zeros are negative 1.25 and 2. So therefore, how many solutions are there in this case? How many solutions are there, Emery? 2. Peace sign, right?
Sure.
Yeah. Right? 2 x-intercepts, so 2 zeros, therefore 2 solutions. Okay. Good. So let's just do a little sketch here. Put on something like this.
Ah, you know.
What's that?
That works.
Something like that. Negative 1.25 and 2 and 0. Okay, so that's easy enough, right? That's why chapter 6 was pretty much getting familiar with your calculators. Now we're kind of getting into like more algebra and stuff. All right, questions? Just getting your notes down. Okay, while you're doing that, I'm going to start punching our next function into Desmos. So the flight path of a water skier is modeled by the function. I hope that it doesn't kind of throw you off because it's in a backwards order. But we have 5.0 plus 24.46 x minus 4.9 x squared. Okay, so here is our function. Okay, so h of t is, you guys all good with that? Okay. Perfect. So here's our function right here. H of t, so that is our y-axis, right? Anytime that you guys see like a h of t or an f of x or something, that is essentially saying y is equal to that, okay? It's just like a fancy notation to confuse students, okay? So don't be confused by that. So h of t, so that's the y-axis is the height of the jumper, and t is time, okay? So x-axis is time. So here's our function. It's asked, how long was he in the air for? Okay, write a quadratic equation and solve using your calculator. Okay, so how would that look at as a quadratic equation? Well, you guys have, so this would be a function, right? Remember, functions equal a variable. What do equations equal?
A number.
A number, good.
Put the height.
And if we're looking for how long was he in the air for, what number are we looking for?
The time.
Yeah, the time. Good. Okay, so our function is going to look something like this, right? So Emery, you're absolutely right. We're going to be looking for that time. Yeah. What's another word for that? No. Time is good. What is this on?
X.
Oh,
Yeah, so this could be our x-intercept, right?
No, it's not.
What do we know about y at our x-intercept?
axis or y is equal to 0.
Y is equal to 0. Very good. Okay, so we're going to rewrite this as a quadratic equation. So 0 is equal to, and then I'm going to rearrange this. We want to go highest degree to lowest degree. So negative 4.9 t squared plus 24.46 t plus 5. Okay, and how long was he in the air for? So you can just find, what did you get?
2.5.
2.5. You sure?
Wait, no, 2.1.
Right.
5.1.
That sounds better, right? So we just jump to our Desmos, and we're gonna look for our vertex or our x-intercept, which is right here. Why isn't this working for me? Oh, because I'm in pen mode. Got
Use
it.
the pen equation.
Go away. There we go. Well, you can't see it anyways. Man, Desmos is not having a day.
5.189.
Delete. There we go. There we go. 5.189 or 5.2 if you round to the nearest tenth, right? So, T is equal to 5.2 seconds. And you're absolutely right, Emery. It does not state that. But
It's common around though.
definitely something to like watch for in questions, right? So here we're gonna have 5.2 and 0 is a norm-ordered pair. Good. Okay. Next question is, when is the water skier 15 meters in the air? When is the water skier 15 meters in the air? So let's say this is y equals 15, right? Y is equal to 15. So we want to find this particular point, right? And this one. Because those are the 2 points where he is at 15 meters in the air, right? Does that make sense?
Yeah.
Logan?
Mm-hmm.
Yeah? Okay. Good. So we can solve this 2 ways. And the first thing that we could do is write a new quadratic equation, okay? So we are not at, what is our y equals at y equals 15?
Y equals 15.
Yeah.
15.
15, right? Yeah. Okay, good. So we're gonna have 15 is equal to negative 4.9 t squared
Yeah.
plus 24.46 t plus 5. Okay, so one strategy, okay, is writing a new equation and finding the new zeros. Okay, so that's what we're doing here. So write a new equation and find the new. So that's strategy 1. And strategy 2 is, so graph y equal 15 and find intersection. Okay, so we'll just do strategy 1 first. So 15 is equal to negative 4.9 t squared plus 24.46 t plus 5. So again, we just want to get this equal to 0, right? So how am I going to get this function equal to 0?
I'll take 15 away.
Yeah, let's take the 15 away, right? So negative 15, negative 15. So then we get 0 is equal to negative 4.9 t squared plus 24.46 t. Positive 5 minus 15 is negative 10. Okay, so we can graph that now. So I'll leave that up there for you guys. And I'm going to graph our new function. You guys ready?
Yeah.
Okay. So, get out of the way. So here is our original function, right? This is negative 4.9x squared plus 24.46x plus 5, right? So with that, we found our 5.2 seconds. Okay, but now we're concerned with when is the water skier 15 meters in the air. Okay, so the second strategy that we did, we could plot, we can also graph y is equal to 10, right? And find the intersection points. Okay? Do you guys know how to find intersection points on your calculator?
Yeah.
Yeah?
You would
Yeah, second calc intersection. You go on one line, you go on the other line, you kind of guess.
Yeah.
Okay? Cool. So you find the intersections. Okay? So I have 0.214 and 4.78. Okay, and then when I graph our second one, should have 0.4. What is our x equal? Why is our x not? Oh yeah, here it is right here. Right? So our new zeros on our new function, so let's get rid of these fluffs. Right? New zeros are 0.4 and 4.5. Right? And then, so that is when we changed our function. So we subtracted that 15 from both sides. Okay? In this case, and sorry, we wanted to know when y is equal to 15. So up here, then we're also going to get 0.4 and 4.5. Okay, so we get the same values. So we could either find the intersection points between our original function and whatever height we're concerned about. Or we could also find the zeros. Okay, so note that they have the same value. So 0.449, 0.449, and then you get 4.543 and 4.543. Okay, so there's two ways to solve for that one. Okay. So example 3, try this one on your own. All right, so two strategies to do this. So one, we can first expand this 2x 4 minus x, so it looks kind of a little bit more like a quadratic, and then we can simplify and get it all to one side, so it is set equal to 0, okay? So 0 is equal to 5x squared minus 14x plus 5. So if we were to graph this using our graphing calculator, which you can use today, it's going to look something like this. Right, happy A. And then our intercepts, I got 0.4 and 0 and 2.4 and 0. Okay, so 0.4 and 2.4. Yeah, good. And this is 0.42 and x equals 2.38. I just rounded, so I had more space on there. Okay, just so you know. Okay, so those are my two solutions. Okay. Okay, so now we'll do the find intersection points. So your y1 is going to be, it doesn't really matter what you say is your y1 or your y2. Okay, I just said 3x squared minus 6x plus 5 is my y1. Okay, and then what did we have over here?
So we had found 2x.
2x, oh yeah, there it is right there. So we had negative 2x squared plus 8x is y2. Okay, so y2 is a sad parabola. So it's gonna go something like that. This is y2. And let's let y1 be blue. And it looks something like that. Okay, so we are concerned where these two lines intersect.
Right there.
Okay, those are when they are equal to one another, right? So you can just find your intersection points using your calculator, right? Second, trace, intersect. And I got 0.4 and 3.0. And I also got 2.4 and 7.7. Okay, so again, we get x is, and I rounded it, but x is equal to 0.42, and x equals 2.38. Okay, now we need to verify our answer. Okay, this is kind of new, but not really. Okay, so check. So, is what we can do to check our answers. We can substitute in x is equal to 0.42 into our y1 and y2 and make sure they equal one another. Okay, and we will do the same thing with x is equal to 2.38. Okay, so our one function, we have 3x squared. 3x squared minus 6x plus 5 at x equals 0.42. Okay, so 3, now we're just going to substitute in x for every time that we see an x, right? So 3 times 0.42 squared minus 6, 0.42 plus 5 is equal to 3.0092. And now we will check the 2x 4 minus x at x equals 0.42. So 2.42 multiplied by 4 minus 0.42 is equal to 3.0072. I mean, it's off by a
Yeah, it'd be like,
10/100th, 1,000th. I always have difficulty saying that. But this is good. This is good. Okay, so x is equal to 0.42. That is close enough. Okay, and then same thing, except for you're just going to do it at your other x-intercept or your intersection points. So at x equals 2.38. So let's do the same thing here. So 2.38 squared. Put my bracket there. Minus 6. 2.38 plus 5 equals 7.7132. And then 2x, x minus 4 at same thing. So 2 times 2.38 multiplied by 2.38 minus 4, which is equal to 7.7112. And again, that's off by 0.02.
Yeah.
So that's okay. Okay, we'll stop there and we will finish this off tomorrow.